Right, can you all hear? Online people? Can you all hear? Yes, right. Sharif, okay. Skiya, Abdullah, right. Right, okay, here. Online students, do you all have the tute on hand? Do you all have the tute on hand? Yes, those who have the tute, good. Those who don't have, it's there in the Telegram group. However, I'll put it to the chat box as well. Right, it's there in the chat box. Right. Motion under straight line. This is the second lesson in grade 10. This is the second lesson in grade 10. Grade 10 is now first lesson is there, but I'll start with grade second lesson because it's a very interesting lesson to learn, and it's somewhat hard as well, isn't it? It's somewhat hard as well. So it's an interesting and a little bit harder lesson to learn more than the first lesson. So we'll start with the second lesson. Later I'll do the first lesson, right? Motion under straight line. Motion under straight line. Motion under straight line. This is the lesson. Those who don't have the tute, write the heading of the name. Heading of the lesson. Motion under straight line is second lesson. Motion under straight line is second lesson. Those who won't, write down the heading. Write down the heading. Motion under straight line. Right. Now listen. Listen very carefully. Under motion under straight line, remember this lesson is a physics lesson. What type of lesson? It's a physics lesson. In physics, we mainly learn about what? We learn about quantities. What we learn about? We learn about quantities. Quantities means something that has values, something that has magnitudes. So we learn about quantities in physics mainly. We do multiplication with quantities. We do division with quantities. We write equations to do that. That is what we learn under physics. So we deal with what? We deal with quantities. So when you look at quantities, I'll write it as physical quantities. Physical quantities. These physical quantities, there are two types. Physical quantities, quantities that comes in physics, there are two types. What are the two types of physical quantities we have? We have scalar quantity. We have scalar quantity. And we have vector quantity. We have vector quantity. Then what are the two types of quantities we have in physics? Scalar quantity and vector quantity. We have scalar quantity and vector quantity. What are scalar quantities? Scalar quantities only have got what? Magnitude. They only have a magnitude. That means they have only values. They have only a number. Do they have a direction? So only one thing they have. What is it? Magnitudes. Magnitudes. They have only magnitudes. What about vector quantity? Vector quantity has two things. What are they? A magnitude and a direction. So vector quantities have a magnitude as well as they have a direction. They have a direction. Now I know this is very confusing. So most of even my 2022 batch students, for them still some quantities are confusing. They tell us scalar is something that has magnitude and direction. They confuse this. I'll tell an easy method to learn this. A, B, C, D in alphabet. S comes first or B comes first? S comes first. D is at last. So S comes first. first with what comes first is S. Then what comes second is going to be what? B. S comes first. Scalar quantities only have one thing. What is it? B comes second. Second means number 2, right? So it has two things. What are they? Magnitude and a direction. Learn like. Clear? Understood? Then tell me. Physical quantity, there are two types. What are they? Scalar quantities and vector quantities. Scalar quantities only has one thing. What is it? Magnitude. Vector quantities have two things. What are they? Magnitude and direction. Shall we write down? Those who don't have the tudes, right there. Scalar quantities. Scalar quantities. Scalar quantities. Under that, write down. You all have it. Huh? Under that, write down. Scalar quantities are quantities. Scalar quantities are quantities. Scalar quantities are quantities with only magnitude. With only magnitude. With only a magnitude. With only a magnitude. Next one, write down. Those who have the tudes, you all have it already. Those who don't have the tudes, write their vector quantities. Write their vector quantities. Write their vector quantities. Under that, write down. Under that, write down. Vector quantities are quantities. Vector quantities are quantities. Tell me. Vector quantities are quantities with magnitude and direction. Right there. Vector quantities are quantities with magnitude and direction. Vector quantities are quantities with magnitude and direction. Vector quantities are quantities with magnitude and direction. What are the examples of scalar quantities? I'll write about 3 which we will be learning. Some we will be learning today. Distance. Distance is a scalar quantity. What about speed? Speed is a scalar quantity. You will understand about them today because we will be discussing speed and distance. What about mass? Mass of an object. When you tell mass of an object, do you tell a direction? 50 kg to the right, 70 kg to the left. Do you tell like that? Never you tell like that. So mass has only magnitude. It doesn't have a direction. So mass is a scalar quantity. These are few examples for scalar quantity. Vector quantities, what are the examples you can give? Displacement. Displacement, it's an example for vector quantity. Today we'll be learning about displacement, so no need to worry. Velocity, velocity, it's also an example for vector quantity. This also we'll be learning today. What about weight? Weight of an object. Now you will tell me, sir, weight of an object. When we tell weight of an object, we don't tell a direction. No, actually we don't tell a direction, but actually weight is acting which direction? Downwards. When you take an object, its weight will always act downwards. So weight has a direction or not? It has a direction. So weight is a vector quantity. Velocity, displacement are vector quantities. We'll be learning about them today. Scalar quantities examples are distance, speed, and mass. Clear? Understood? Let's write. Under scalar quantities itself, right? Under scalar quantities itself, right? Under scalar quantities, example. Distance, speed, mass. Yes, force is also example for vector quantity. Very good. Force is also vector. Yeah. Right there. Example for scalar quantities. Distance, speed, mass. Example for vector quantity. Displacement, velocity, weight, force, all those things, whatever you like, you can write. Displacement, velocity, weight, all those things. Okay, right. Now people, we very well know distance, speed, they are scalar quantities. Displacement, velocity, they are vector quantities. Today we'll be studying about each one of them. That means we'll be studying about distance, we'll be studying about speed, we'll be studying about displacement, we'll be studying about velocity. Those who don't have a tute, write down a subheading distance. We'll see what is distance. Those who have the tute, you have it already. Subheading distance. Subheading distance. Right. Now look, all of you look, look very carefully. Distance. Let's take, you wanted to go from A point to another place called B point. A point to B point you wanted to travel. Let's take, you don't have a road from A to B straight. This dotted line, there is no road. You don't have a road. You have a road or a path like this. You have another road or a path like this. All of them are connecting what and what? A and B. You have another path going like this. I'll name this as P path, this as Q path, and this as R path. So you have three paths to go from A to B: P path, Q path, and R path. Let's take P path is 320 meters long, Q path is about 200 meters long, R path is about 100 meters long. Now you can see between A and B, if you go in P path, you are covering how much of length? 320 meters. Then we say distance between A and B in path P is 320 meters. If you go in Q path from A to B, how much of length you are covering? 200 meters. Then we say distance from A to B in which path? Q path is 200 meters. If you travel in R path, you are covering from A to B 100 meters length, then we'll make it 200. No? What's given into you? 200. 200. We'll make it 200. You are covering 200 meters length, then you say distance is 200 meters. Then what does actually distance means? Distance means the length from initial point and final point. The length between initial point and final point. So you can see the length here is going to be 320 meters, then distance is 320 meters. The length here is going to be 200 meters, then distance is 200 meters. Length here is also 200, then distance is 200. Then we can write distance of, or distance traveled in path P. Tell me, in path P, what is the distance traveled? 320 meters. In path Q, what is the distance traveled? 200 meters. In path R, what is the distance traveled? Again 200. Very simple idea. So again, what is the definition of distance? The length between starting point and initial point. That's it. Clear? Let's write. Let's write. In the tute, now those who don't have a tute, quickly draw like this. Quickly draw like this. And now those who have the tute, quickly write down. In the tute, you have distance of path. Those who don't have the tute, write this. Distance traveled in. First on path P is given. You all feel it. Path P how much? 320. Path Q 200. Path R 200. Fill it. Those who don't have the tute, write this full thing. Okay, quickly write. You started grade 11 lessons in school. Still no. Third. Then you are in grade 10 third. Okay. So this is my first day here. Online people, you should have come to the morning seminar. Morning only you all have. Next week I'm starting photosynthesis. If you get a free time, you can join. Finish? Under that, let's write down. Distance is the length between initial point and final point. Initial point and final point. Distance is the length between initial point and final point. Initial point and final point. Tell me, does it depend on the path we go or not? See, path P, different distance. Path Q, different distance. Path R, different distance. So does it depend on path or not? It depends on the path we go. If you go a long way from somewhere and come to B, still it depends on that path. So the distance will change. So remember, distance will always depend on the path we take. If you go a longer path, your distance is longer. If you go on a shorter path, your distance is shorter. Let's write. Distance depends on the path we take. Distance depends on the path we take. Distance depends on the path we take. Now a very important question. Distance is a scalar or vector? It's a scalar. It's a scalar. Why it is a scalar? Because it doesn't depend on direction. I'll show that now. See, person start from point A. I'll take path P. I'll take only path P. Only path P I'm going to take. Person start from point A. Initially he is working upwards, isn't it? Initially he is working upwards, so his direction is upwards. If he walks continuously upwards, can he reach B? So after some time, his direction changes. He walks. After some time, his direction changes. Somewhere here, his direction is this side. From upwards, he has bent a little bit this side. Now, when he goes in this same direction, will he reach B? Again, after some time, his direction changes. Somewhere here, his direction changes. Again, after some time, his direction changes. Again, after some time, his direction changes. Again, after some time, his direction changes. Then again, after some time, his direction changes. And you can see from point to point, his direction is what? Changing. Then can you tell one single direction for the full path? If you tell he traveled upwards in path P, he won't go here. He will go somewhere up. So he didn't go upwards in path P. Again, after some time, he changed his direction. So from point to point, he is changing the direction means, can you tell one single direction for the full path? No. If you can't tell one single direction for a full path, we tell there is no direction. That means it is a scalar quantity. Clear? Understood? Another one more point. Distance is a length, right? Then what is the unit to measure distance? Meters. Standard international unit to measure distance is meters. Okay, let's write it. Right there. Distance is a scalar quantity. Distance is a scalar quantity. Distance is a scalar quantity. Online people, is it clear or is everything clear? Distance is a scalar quantity. Full stop, continue. SI unit to measure distance is SI unit to measure distance is SI unit to measure distance is write in words meters inside brackets simple m, meters simple m, meters simple m, meters simple m, meters simple m. Okay, now the basics about distance you all have an idea. Next we move on to the next concept, that is called as displacement. What's it? Displacement. Those who don't have a tune, write down the heading displacement. Those who don't have a tune, quickly write down a heading displacement. Right. Displacement. Now, what does this displacement means? Remember, displacement, when you are giving the meaning, you need to consider two important points. You need to consider how many important points? Two important points. Displacement is the shortest possible, that is the first point. Displacement is the shortest possible, you need to have that word. It's the shortest possible linear length between the starting point and the end point. So what is displacement? It is the shortest possible, first keyword, linear length. What do you mean by linear length? What do you mean by linear length? Remember, linear length means a straight line length. It cannot be a curved line. It is a straight line length. So displacement is the shortest possible. It should be shortest. Can it be a curved path? No. Linear length between what and what? Initial point and end point, or starting point and finishing point. So if someone asks you what is displacement, what are your two key points in your answer? Shortest possible, linear length. Then tell me the full definition for displacement. Displacement is the shortest possible linear length from starting point to end point, or from initial point to end point. Clear? Understood? Let's try. Displacement, under that, write down. Displacement is the shortest possible linear length between the starting point and the end point. Between the starting point and the end point. Between the starting point and the end. Between the starting point and the end point. Online students, everything clear? Any doubts? Okay. Everything clear? Yeah. Yes. Okay. Abdullah, right? Askia, Hamir. Okay. Right. Okay. So it's the shortest possible linear length between the starting point and the end point. That is what we define as displacement. We'll take an example. The previous example. Fellow went from A point to B point. Fellow went from A point to B point. Fellow went from A point to B point. You all tell me what is the length between AB and 100. What's the length between AB? It's 100 meters. Can you all see it is the shortest possible distance, or it is the shortest possible length? Why? All the other path will surely become bigger than 100 meters, right? Because this is a linear length, all the others are curved length. Then when you take a curved path, it is going to be greater than 100 meters. So this is the shortest possible length. Next one, isn't it linear? Yes, of course it is linear. It's a straight line. Yes, of course it is linear. It's a straight line. Then what is the displacement between A to B? 100 meters. But remember, displacement is a vector quantity. What type of quantity? Vector quantity. Vector quantity means they have a magnitude as well as a direction. See, if I tell the direction of this displacement, see, he started from A. He walks in, I'll draw the direction scale here. North, east, south, west. He started walking towards which direction? East direction. He goes a little bit, still he is walking towards which direction? East direction. He's walking a little bit, still he is going towards which direction? East direction. He's going a little bit, still he is walking towards which direction? East direction. He's walking a little bit, still he is going towards which direction? East direction. He is at the final point, still he is walking towards which direction? East direction. That means throughout his journey, his direction is what? Same, it is east. So you can tell from A to B, he has displaced 100 meters east direction. When you told about distance, you couldn't tell a direction of y. From point to point, direction change. But here, point to point, the direction doesn't change. Therefore, you can guarantee tell a direction. Therefore, displacement is a vector quantity. Clear? Understood? Let's write down. Displacement is a vector quantity. Just there, it's a vector quantity. It's a vector quantity. It's a vector quantity. It's a vector quantity. Tell me, what's the unit to measure displacement? Meters. Why meters? It is also a length measurement, right? All the length measurements, we use what? Meters. All the length measurements, we use meters. Right there. Unit meters. Bracket simple length. Unit meters, bracket simple length. Unit meters, bracket simple length. Unit meters, bracket simple length. Now you might tell, sir, only here you can tell a direction, right? For other displacement also, can we tell a direction? Of course, yes. See, displacement is a linear length, right? That means always you get what? Straight lines. Let's take A to B. This is the displacement. This is a straight line. Can't you tell the direction? Yes, north, towards north. Let's take this direction. Upwards to downwards, A to B. Straight line, displacement is a straight line, A to B, downwards. Can't you tell a direction? Yes, what's the direction? South. Let's take A to B, this direction. A to B, this direction. Can't you tell a direction? What's the direction? Towards west. Now see, A to B, this direction. A to B, this direction. Now can you tell a direction? Of course, yes, you can tell a direction. Why? This is here. What is that? Northeast. There you go. You can tell a direction, northeast. Let's take this direction. A to B, upwards like that. Now can you tell a direction? Of course, yes. What's the direction? Northwest. There you go. Now you can clearly see for any displacement you can tell a direction. Why? All are straight lines. Straight lines have a direction. But if you look at a curved path, it won't have a proper direction. It keeps changing. You can't tell a direction for curved path. But in displacement, we are not talking about curved path, right? We only talk about linear path. All the linear path, you can give a direction. Clear? Understood? Let's try. What did I tell last? Unit I told, vector quantity. Then nothing to write. Nothing. Now we are going to differentiate between displacement and distance. What are the differences between displacement and distance? Differences between displacement and distance. Online students, you all have a table already drawn. Others, please quickly draw a table of 2 columns. A table of 2 columns. A table of 2 columns. Right. Now look at the board. Look at the board very, 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 very carefully. I'll draw one side distance. This is distance. This side I will take as displacement. This side I'll take it as displacement. Tell me, distance is a scalar or vector? It's a scalar. Distance is a scalar quantity. What about displacement? It's a vector quantity. It's a vector quantity. Does distance have magnitude? Of course, yes, it has magnitude. I'll write have magnitude. Have magnitude. Does displacement have magnitude? Yes, it also have magnitude. This also have magnitude. This also have magnitude. Does distance have a direction? No direction. Distance, no direction. Distance, no direction. What about displacement? It has a direction. Has direction. You can write have direction. Have direction. Clear? Understood? Quickly write down. Right, that's it. Then distance, you all know it's just the length between starting point and finishing. What about displacement? It is also a length, but it is the shortest possible linear length between starting and end. And we can give a direction for that as well. That's all you should know about distance and displacement. We'll do some questions. Now all of you take your tutes. Those who don't have the tutes, you can use a PDF because we are doing questions. Take your tute. Question number 1. Example 1, question number 1. Do with me. Example 1, question number 1. Example 1, question number 1. A, B, C, D is a path they have given. A, B, C, D path is given. A point, B point, C point, and D point. AB how much length? 100 meters. BC 50 meters. CD again 100 meters. They are telling fellow is walking from where to where? A boy starts his journey from A and reaches D through BC path. That means start from here, reaches D through what? Through BC path. So fellow walks in this direction. Right. Calculate the distance boy has traveled. What is the distance boy has traveled? What's the distance? AB 100 meters, BC 50 meters, CD 100 meters. Altogether how much? 100 plus 100, 200, 250 meters. Total distance boy has traveled is 250 meters. Question number 2. What is the fellow's displacement? See, displacement is the shortest possible linear length between the starting point and end point. So what you do is you keep a ruler between A and D, you draw a straight line. So this is his displacement. Have they given the length? 150 meters. Then directly tell me what's the displacement? Directly 150 meters. Directly 150 meters. Directly 150 meters. Third one. What is the fellow's direction? This direction means here. That is what direction? Southeast. Towards southeast. Towards southeast. Okay. Towards southeast. Very simple questions, huh? Very simple questions. Go to question number 2. Go to question number 2. Do question number 2. Online students, send me the answers for question number 2. Do and send me the answers for question number 2. Check. Right. Many people have sent the answers. We'll see. Question number 2. A girl travels in the path ABC. What's your path? There you go. A point is here. C point is here. This is the path. ABC. ABC. ABC length is 350 meters. AC length is 100 meters. They're asking what? Distance, displacement, direction. Very simple. What is the distance she has traveled? 350 meters. What is the displacement she has undergone? 100 meters. What's the direction? Towards south. Now go to question number 3. Question number 3. Question number 3, answer the first question, second question. Direction, just keep it. I'll help you all. Direction, just keep it. I'll help you out. Right. Third one. An athlete runs a 200 meters race as shown from A to B on a curved track. What is the distance, displacement, direction of displacement? Fellow is running how many meters? He is running 200 meters. He is running 200 meters. So this full length is 200 meters. 200 meters. So what's the distance? 200 meters. Those are very simple. First one, 200 meters is the distance. Second question, what is the displacement? He started here, he has end here. That means what is his displacement? 160 meters. 160 meters. 160 meters. Now third one, what important? Third one, see. Third one, now you know this direction is northwest, but you can't just tell northwest because when you look at the diagram, they have given you the angle. Can you see? They have given you the angle. North is there, west is there, and here they have given an angle of 70 degrees. People in maths, you all learn angles, right? Why do you learn angle? Why does angles? What is the use of angles? Actually, angles are used to give directions. Actually, angles were used to give directions. See, if I wanted to go in this direction, then I can tell a certain angle, right? 10 degrees, 20 degrees. If I wanted to walk here, I can tell 90 degrees. If I wanted to walk this side, from this side towards this side, 180 degrees. So angles can be used to represent what? Directions. Here you can see he has a displacement of 70 degrees from north to west. So what is his direction? Not just northwest, 70 degrees from north to west. That means he stands in the north direction and he turns how much of angle? 70 degrees towards west. Clear? And he starts running. Clear? So what is his direction? You can't just tell northwest. Now you can tell 70 degrees from north to west. Clear? Online people? So might be in maths when you were studying angles, you might be wondering what's the use of this? You very hard to study. Now that's the use. That's the use of angles, right? That's the use of angles. Go to fourth one. Go to fourth one. Go to fourth one. Once done, send me the answers for the fourth one. Today? Once done, send me the answers. Right. Question number 4. Question number 4. You have school, home, and shop. You have school, home, and shop. You have school, home, and shop. School, home, shop. School, home, and shop. What are the lengths? School to home, 100 meters. Home and shop, 50 meters. Home and shop, 50 meters. Now, what is the girl doing? A girl starts her journey from home and travels 50 meters to the shop and then goes to the school, passing her house again. So she starts here, goes to the shop, goes to the home, and goes to school. So goes to school through home. That's her school journey. Then what is the total distance she travels? What is the total distance she travels? First she goes from home to shop. That means first she travels 50 meters. Next, what happens? From shop, she passes the home and goes to school. So we'll consider the passing of home first. Shop to home, another 50 meters. So you add another 50 meters. From home to school, another 100 meters. So totally how much of distance she has traveled? 200 meters. Total distance is 200 meters. Right? Second question, what is the displacement of girl? Now, what is the displacement of girl? First of all, tell me the definition of displacement. Shortest possible. Linear length between starting point and end point. Where is she starting? Home. Where is she finishing? School. Then do we need to consider going to shop and coming? We need to consider because only distance depends on the path. Did I tell displacement depends on path? No. Only distance depends on path. When you calculate distance, you need to fully consider the path. When you consider displacement, you don't need to think about the path. You should only think about the starting point, end point, and the linear length between them. So starting point is here and the end point is here. What is the linear length? 100 meters. So her displacement is 100 meters. Something to learn from this. Now, let's take, I wanted to go from here to the end of this room, end of this classroom, I wanted to go. Then what I'm going to do is I'm going to go out, I'm going to go around the class, again come here. Then my distance, if I am calculating, I need to calculate the whole length I walked. But what's my displacement? The meaning of displacement is where you have displaced. I was initially here, after some time I have got displaced to that end. So should I consider the full length I walked? No. I was here, finally I got displaced there. Then I need to consider here to there, what's the length? That is my displacement. I got displaced. Distance is all the way I walked, all those lengths you need to consider. It's something like this. Now, when you're going from sometimes from classroom to your washroom, there's a meme also for that. You don't go directly from classroom to the washroom. We go to the basketball court, football court, and then slowly go towards the canteen, and then only go to bathroom. When class teacher asks you, she knows you started from classroom, and you will tell, sir, teacher, I went to bathroom. So class teacher is like displacement. You are telling she knows the starting point and you are telling the end point. So she thinks, classroom is here, bathroom is there. So you displace from here to bathroom. So she considers what? Your displacement. But your vice principal, not the principal, right? Principal is not interested about that. Vice principal, head teacher, sometimes security man, those people, they will try to follow you sometimes. They will come in your path. They are like your distance. They are interested about what are the whatever the places you went, all those places they wanted to know. Not the class teacher. Class teacher, when you are in the class, you got up, you went from here to bathroom. That's it, she knows. She knows your displacement. Your head teacher or the vice principal knows your distance. Clear? Understood? So hereafter, if someone tells you distance, Remind your vice principal or your head teacher. So displacement is like your class teacher. Distance is like your head teacher. Because distance is starting point and initial point, how much you have displaced. Distance is the whole length you walk. Right? Clear? Online people clear? Online people clear? Question number 4. Clear? Right. They asking the direction also, no? What's the direction of displacement from here to here? Towards west. Towards west. Towards west. You all tell me something like this, okay? Somebody starting here is going a long way of about 1000 meters and finishing here. What is his distance? 1000 meters. What is the displacement? Starting point and finishing point are same, no? So how much he has displaced? 0. He has not gone from any place to any place. His starting point is also same, finishing point is also same. That means his displacement is 0. Clear? Let's write a small review there. For question number 4, let's write a review. Only distance depends on path. 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 Displacement depends on displacement depends on initial point and final point only. 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 Okay, so get this idea very well. Displacement means you are here, you walk everywhere, after some time you are there. How much you have displaced from here to there? How much you have displaced? Distance is what? How much you have gone fully? That is what distance is. Okay, right. That's all. Distance and displacement. Is everything clear about distance and displacement? Is everything clear about distance and displacement? Online people? Yes. Okay. All clear, no? Right. Those who don't have the tute, write down the next heading, speed. Next heading, speed. Next heading, speed. Next heading, speed. Speed. Right. Actually, for speed, there are two definitions. Both the definitions are standards given in the textbook as well. Both the definitions are standard. You can write any definition for your final exam. Any definition is okay. First definition for speed is rate at which distance traversed is called as speed. That means rate at which distance is transferred. That means Rate of change of distance is speed. Rate at which you change your distance. Rate at which you change your distance. Actually, children, when you hear the word rate, when you hear the word rate, now rate you are defining for speed. When you hear the word rate, that means something is divided by time. That is what rate means. Rate, the real meaning of rate is some sort of a component divided by time, you have rate. Some component divided by time, you get the rate. So here we define rate for what? Speed. So speed is going to be some component divided by time. Now, rate at which distance transfers, right? So what is divided by time? Distance. So here speed is going to be equal to distance divided by time. Speed is going to be equal to distance divided by time. This is the equation for speed. Clear? Again, tell me, what is the definition of speed? Rate at which distance transfers. So rate means always something is divided by time. What is that something? Here distance, because distance with time only we measure. Clear? Understood? This is first definition. This is the equation. I told you there are two definitions. Then what is going to be the second definition? Distance transfers in a unit time is called as what? Speed. Remember again this word unit time. Unit means that should come as the denominator. Unit time, right? Then that time should come as the denominator. If you tell unit mass, then what will come as the denominator? Unit mass, what will come as the denominator? Mass will come as the denominator. Unit time, what should come as the denominator? Time should come as the denominator. Something will come up. It is the distance here. So whatever which is coming up will be defined separately. However, when you hear the word unit something, that something will come as the denominator. So this definition is also correct. This definition is also correct. Both are standard methods of defining speed. Then tell me, what is speed? Rate at which distance transfers. What is the equation for speed? Distance divided by time. What is the other definition for speed? Distance transfers in a unit time. Now tell me, speed is a scalar quantity or vector quantity? It's a scalar. Why? Distance is a scalar. Time is, however, it doesn't have a direction. Scalar divided by something scale. This is also scalar. We consider time as a scale actually. Scalar divided by scalar, you can't get a vector, right? You will be getting again what? Scalar. So speed is a scalar quantity. Speed is a scalar quantity. One more thing. What is the unit to measure speed? What is the unit to measure speed? I'll get it from the equation. Speed equals distance divided by time, right? Distance is measured in what units? Meters. Time is usually measured in what standard international unit? Seconds. So on denominator you have seconds, numerator you have meters. This is going to be m. When you bring s on top, s to the power minus 1. This is the unit of speed. Clear? Understood? Now take out your tutes. Those who don't have the tute, write down heading speed and write all these things. Those who don't have the tute. Those who have the tute, first dotted line, write this definition. First box, write this. Second box, write this. Third dotted line, write this. Once done, tell me done. Man. Right. Ali Reza. Right. Okay. Then what is speed? It's the rate at which distance transfer. What is the unit of speed? Ms to the power minus 1. What is it, a scalar or vector? It's a scalar quantity. All those things we know. Now, people, we need to understand something about two things about speed. One, uniform and constant velocity. Uniform or constant velocity. Uniform or constant actual speed. Uniform or constant speed. Uniform or constant speed. And next, we need to understand about mean or average speed. First, we'll learn about uniform or constant speed. What do you mean by uniform or constant speed? It's like this. Uniform or constant speed, it's like this. Let's take you have an object. It is moving. It is moving. It is moving without any acceleration. That means its speed is not increasing, its speed is not decreasing, it is maintaining the same speed throughout the journey. Such a motion is defined as what? Uniform or constant speed motion. That means you have an object moving throughout its motion, its speed doesn't increase or its speed doesn't decrease. Actually, in practical life, you can't go like that. You go like that, you will knock some and let end up on heaven or earth, hell. Right? You can't go in constant speed always. When you need to slow down, you need to slow down. When you need to fast up, you need to fast up. It's a different story. But remember, if an object moves with the same speed throughout its journey, for example, aeroplanes, right? Some aeroplanes now after the takeoff, they go in the same speed throughout their journey. So you can tell it has a constant speed. So constant speed means same speed is maintained throughout the journey. We can understand this like this. Now let's take, I have an object. I'm going to make it move. When it starts its motion, I'm going to start my stopwatch also. So initially it is at 0 distance. My stopwatch is showing me 0. When it starts the motion, I start the stopwatch. Stopwatch runs the motion of the object also begins. While it is moving, I'm going to calculate the distance traveled in each and every second. And I'm going to plot a table. I'm going to plot a table. I'm going to plot a table with distance and time. With distance and time. With distance and time, I'm going to plot a table. Initially, it is at 0 distance. My stopwatch is showing me 0. Now the stopwatch starts running. I'll write speed on top, distance on bottom. Then it's speed on top. Sorry, yeah, time on top, distance on bottom. Time on top, distance on bottom. Time top, distance bottom. Time you can never stop it. Time you can never increase. Time you can never decrease. No, you can't reverse it. You can't increase. You can't do anything. Time will keep on running. 0, 1, 2, 3, 4, 5, 6. Will take up to 6. That's enough. Time will keep on running. Now what I'm going to do, I'm going to give an object a motion, start the stopwatch. When stopwatch starts running 0 to 1, 1 to 2, 1, 3 to 4, I'm going to calculate the distance. Initially 0, then let's take it goes 3 meters, 6 meters, 9 meters, 12, 15, 18. This is how it moves. This is how it moves. Now, what is the distance traveled in the first second? What is the distance traveled? What is the distance traveled in first second? Now, what does first second means? Initially, stopwatch is showing 0. From 0 to 1 second, that is my first second, right? From 0 to 1 second, that is my first second. From 0 to 1 second, what is the distance traveled? 0 to 3 meters means how much? 3 meters it has traveled. It has traveled 3 meters. It has traveled 3 meters. Next, what is the distance traveled in second? What does second means? Now already the second the stopwatch came to 1 second. It is the first second. 0 to 1 second is the first second. Now it is where at 1 second. 1 second to 2 second is my second second. 0 to 1 is my first second. 1 second to 2 second is my second second. That means 1 second to 2 second is my second second. At second second, how much distance traveled? From 3 meters to 6 meters. Then what is the distance it has traveled in the second second? 3 meters. Here it has traveled 3 meters. Again, look. Stopwatch is initially at 0. 0 to 1 second is my first second. In my first second, it has traveled from 0 to 3. That means it has traveled 3 meters. Now it is at 1 second. From 1 second to 2 second, that means my second second. 1 second to 2 second is my second second. In my second second, how much distance traveled? From 3 meter to 6 meter, how much? 3 meters. Now you all tell me. What is the distance traveled in third second? That means 2 second to 3 second. Now already from 0 to 1 second, first second went. 1 second to 2 second, second second went. 2 second to 3 second, my third second, how much distance it has traveled? 3 meters. Again, it has traveled 3 meters. What is the distance traveled in fourth second? That means where to where? 3 second to 4 second. How much distance? Again 3 meters. What is the distance traveled in fifth second? That means 4 second to 5 second. How much? Again 3 meters. So you can clearly see throughout the motion, distance traveled per every 1 second is how much? Same 3 meters. If it covers same distance throughout the journey in each and every second, that means it is maintaining a constant velocity. True, no? If it goes in the same speed only, for every second it will cover same distance. Otherwise, now let's take vehicle goes, it stops. Then initially it is covering some distance. After that time is going, is the distance going? Distance will be 0. Then is it constant speed? Constant speed means when time goes throughout the journey, it should go with the same speed. That means each and every second it should cover the same distance. See, first second 3 meters, second 3 meters, third 3 meter, fourth 3 meter, fifth 3 meter. If it covers the same distance in each and every second, we call it constant speed or uniform speed. Now, when it travels in constant speed, each and every second, however much long it goes, it is going to cover the same distance in each and every second. Now, then tell me, if a vehicle goes in constant speed, in the first second, it is covering 5 meters. Then what is the distance covered in fifth second? 5 meters. What is the distance covered in 10th second? 5 meters. What is the distance covered in 20th meters? 20th second. What is the distance covered in 20th second? Again 5 meters. Yes, good. Online people. Good. Then again tell me another one. An object is moving at constant speed. Distance covered in first second is 7 meters. First second is 7 meters. Then what is the distance covered in 10th second? 1 meter. 10 second, how much? Yes, very good. 7 meters. Good, online people. 7 meters, Abdullah, right? What is the distance covered? The same motion. What is the distance covered in 100th second? 100th second. Again, 7 meters. Such kinds of motion are called as what? Constant or uniform speed motion. Clear? Understood? Let's write there. Yes. Umar, right? Abdullah, right? Askia, right? Okay, good. Those who have the tube, take out the uniform or constant speed page. Under that, you have a table. Those who don't have a tube, write the heading, draw this table quickly. Draw this table. You all have this distance traveled in first second, second second, third second, fourth second. You all fill this. Those who don't have the tube, write this and fill this. Write this and fill this. Quickly fill. Quickly fill. I'll take some water and come. Quickly fill and keep. I'll take the water and come. Okay, finished. So every 1 second, distance covered is going to be what? Same. Right. Then we tell it uniform or constant speed. Right there, under that, under the write down. If distance transferred, if distance transversed, if distance transversed, in every 1 second, in every 1 second, in every 1 second, in every 1 second, is same, is same, is same throughout the journey, throughout the journey, then we say the motion is, then we say the motion is what type of motion? Constant speed or uniform speed, right? Both, huh? Uniform, what you call slash, right? Slash constant speed. Uniform slash constant speed. Uniform slash constant speed. Uniform slash constant speed. Okay. So now you have a very good idea about constant speed. So remember, constant speed means every 1 second distance covered is going to be same. It can't change. Clear? But tell me, practically, is it possible? I told you no. If we try to travel like that, usually don't try. Yeah, don't try. No, don't ever try to travel at constant speed, because if there is a traffic, you need to brake. It's not GTY, so you can't go like that. So you need to stop when it is needed. When it is when vehicles are not there, then you speed up, right? Then children, in normal life, in real life, most of the time we can't go in constant speed. I don't tell you can't go in constant speed, you can, but most of the time we don't go in constant speed. Sometimes we increase our speed, sometimes we decrease our speed, sometimes we have to stop our vehicle. In such a case, we find something important which is called as mean speed or average speed. What is it? Mean speed or average speed, right? Write down heading mean speed or average speed. Those who don't have that, you write down heading mean speed or average speed. 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 Now look, again I'll do the same practical. Let's take an object. I have the stopwatch. 0 distance, my stopwatch is showing me 0. I give it a motion. I start the stopwatch. I'm going to calculate the distance transferred in each and every second. And I'm going to plot a table. There you go, time. There you go, distance. Tell me, can you stop the time? No, you can never stop the time. It just keeps running. So 0, 1, 2, 3, 4, 5, 6 enough. 6 enough. I'll go with the values in the tute itself. 0, 3, 5, 9, 12, 16, 18. Now tell me, what is the distance transversed in first second? Distance transversed in first second. First second means where to where? 0th second to 1 second. That means 0 second to 1 second from here to here. What is the distance transversed? 3 meters. First second fellow is going 3 meters. First second fellow is going 3 meters. If it is a constant speed, what should happen? Throughout the journey, for every 1 second, he should go in 3 meters. We'll see. We'll see whether he's going in 3 meters or whether he's going in different distances per each time. What is the distance transversed in second second? Second second means what? 1 second to 2 second. from here to here. What is the distance traversed? From 3 to 5, how much? 2 meters. There you go. Second, 2 meters. What is the distance traversed in third second? Third second means where to where? 2 second to 3 second. What is the distance traversed? 5 to 9 means how much? 4 meters. 5 to 9 means 4 meters. What is the distance traversed in first second, third second, fourth second? Fourth second. In fourth second, how much distance traversed? 3 meters. Now can you see each and every second distance traversed is changing? Then is it constant speed? No. Is it uniform speed? No. Children, here speed is changing from time to time. Then we define something called mean speed or average speed. What does average speed means? As an average, what speed he went throughout the journey, he maintained almost this speed. Almost he went in this kind of a speed. That is what we define by average speed. Did he really go by that speed? No. Almost he went in that speed. That's what we try to tell by average. How do you find average? You take the total distance divided by total time. You have what? Average speed or the mean speed. So the equation for average speed or mean speed is mean speed or average speed. Equation is going to be what? Total distance divided by total time. Total distance divided by total time. This is the equation to find average. Now, sometimes in your schools also, in the report card, they might write average marks. How do they find the average marks? They take all the subjects, they add everything, they get the total, and they divide by number of subjects. That's what we are doing here also. Total distance we are dividing by total time. From there you get the average speed. Average marks actually means what? In your exam, average marks means what? Let's take average marks is 70. What does 70 means? You almost took for all the subjects about 70. Did you get each and every? Now, did you take for all the 9 subjects 70? No. Average is 70 means you almost took around 70, not exactly 70 for each and every subject. Same concept here. The average or mean speed that you get is you traveled almost at that speed, not exactly at that speed. Tell me the average speed here. What's the total distance? What's the total distance? 18 meters. What's the total time? 6 seconds. What's the average speed? 3 meters per second. That means every second he has traveled 3 meters. That is what average speed means. Did he actually travel 3 meters every second? First second, correct. Second he traveled 2 meters. Third second he has traveled 4 meters. But almost around 3 meters, right? Fourth second he has traveled again 3 meters. So you can see average speed is not the exact speed. It is almost, it tells that he traveled almost at that speed. Clear? Understood? Let's write. Mean speed, average speed. Online students, those who don't have the tube, draw the table and write down this distance traveled in first second, distance traveled in second, distance traveled in third second, distance traveled in fourth second. Those who have the tube, you should just need to fill it. Just need to fill it. After filling it, write the equation. Write the equation. Once done, tell me done. Huh? And online students, now this whole month I'll be doing free. Yeah? This whole month, now this lesson, and I'll be starting the next lesson, that is about what you call matter, right? Structure of matter. All those lessons I'll be doing free. So online students, you can tell your friends also. If you have any friends in grade 10, tell na, inform. Physical also, it will be fully done free this month. And those who wanted to contact me, you can contact me. Note 71 910 is there in the tutor. I think all of you all are there in the Telegram group. Are you there? Online students, if you are not there in the Telegram group, tell and get into the Telegram group, or at least the WhatsApp group, anything. Right, we'll do the questions. Right now, those who have the tute, those who don't have the tute, everyone need it. Those who don't have the tute, take the PDF. Huh? Take the PDF out. Go to example number 5. Go to example number 5. Under mean speed and average speed, go to example number 5. Go to example number 5. The total distance traveled by a car. We have what? Total distance. Total distance is how much? Total distance traveled by a car is 50 meters. 50 meters. And the total time duration is how much? 5 seconds. What they asking? Calculate the average speed. So total time is 5 seconds. How to find the average speed? Average speed is equal to total distance over total time. There we go. Average speed equals, you need to write the equation and start. Total distance divided by total time. What's the total distance? 50 meters. What is the total time? 5 seconds. Please substitute with the units. If you don't write the units, no marks. Then what is the average speed? 10 ms to the power minus 10 ms to the power minus 1. Do question number 6, 7. Question number 6 and 7. Before starting question number 6 and 7, just a reminder. 1 kilometer equals how many meters? 1000 meters. Use that. 1 kilometer equals 1000 meters. Do question number 6 and 7. And send me the answers. Question number 6, 7, and 8. Only one more question is there. Do 8th also. 6, 7, 8. Finish. Online students, did you all finish? 6, 7, 8. Abdullah, right. Okay, no? Right. 6, 7, 8. Okay, you see. Question number 6. A train travels from Colombo to Mardana in 100 seconds. So actually that is the total time, 100 seconds. If the total distance traveled is 1 kilometers, now what? You need to convert kilometers to meters first and then calculate the average speed. 1 kilometer equals how many meters? 1000 meters. Now you can start the question. Average speed. Average speed equals, you need to write the equation and start. Total distance divided by total time. What is the total distance? 1000 meters. What's the total time? 100 seconds. So what is the speed? Average speed. Average speed is 10 ms to the power minus. Clear? Got it? Question number 7. Question number 7. During a bus during a school trip covers a total distance of 6 kilometers. 6 kilometers means how many meters? 6000 meters. First show it. 6 kilometers equals 6000 meters. In 5 minutes, time is given in minutes. 5 minutes. 1 minute is how many seconds? 60 seconds. Then 5 minutes is 5 into 60 seconds. 1 minute is equal to 60 seconds. Therefore, 5 minutes is equal to 5 into 60 seconds. How much? 300 seconds. You have the total time, you have the total distance. They ask you what? Average speed. Average speed, total distance over total time. Over total time. What's the total distance? 6000 meters. What's the total time? 300 seconds. What's the average speed? Yes, 20 ms to the power minus. Question number 8. No doubts, no? Over there. Question number 8. Question number 8. A speedboat travels from A to B, a distance of 10 meters in 5 seconds, and then B to C, a distance of 50 meters in 25 seconds. A to B and then B to C. Is it without stopping? Yes, without stopping. A to B, how much distance? 10 meters in how many seconds? 5 seconds. B to C, how much distance? 50 meters. How many seconds? 25 seconds. Question 1. What is the speed of the boat in the journey from A to B? Speed equals, there you go. Speed equals to distance divided by time. What's the distance? A to B journey 10 meters, time 5 seconds, then 2 meters per second. Did you all get it? 2 meters per second. Second question. What is the speed of the boat in the journey from B to C? Again, same equation. So I'm not going to write the equation. speed equals, what's the distance here? 50 meters. What's the time taken? 25 seconds. What's the speed? 2 meters per second. 2 meters per second. Question number 3. Comment about the nature of motion. Tell me, what can you tell about nature of motion? Uniform or constant speed. Why? Here also it has traveled in 2 meters per second. Here also it has traveled in 2 meters per second. That means throughout the journey it has gone in the same speed. Such kind of motion is called as what? Constant speed or uniform speed. You can write one of them. Uniform speed motion. Uniform speed motion. Yes, I checked your chats. Correct. Okay. So speed, uniform speed, constant speed, mean speed, average speed. Are you okay? Online students, are you okay with that? All those sections. Speed is done. No? Okay. Now we'll take a break. 15 minutes break until now 5:20. No? 5:20. No? It shows 5:18, 19, 5:17. Take a 15 minutes break. Then come by 5:32. 5:32. Okay. Online students, don't leave me. Just keep it and you can do your work and now. right? Okay, na? Back to work. So speed, distance done, displacement done, speed done. Next is what? Velocity. Now, when you understand speed, velocity is very easy, but little bit of concepts change, but almost the theories are same. Online students, those who don't have the theory, write down heading velocity. 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 People, velocity is also similar like speed, but the equation for velocity is speed equation was distance divided by time. Velocity equation is displacement displacement divided by time. So you can see it's almost like speed. What is the only difference? Instead of distance, we write displacement. So displacement divided by time is velocity. Then children, it is almost similar like speed, right? What's the only difference? Displacement. Then tell me first of all the definition of speed. First definition of speed was rate at which distance transferred. Rate at which distance transferred. So what is the definition of velocity? Rate at which what is transferred? Displacement transferred. Definition of velocity is rate at which displacement is transferred. Actually transversed. Tell me another definition for velocity. For speed, we had another definition, right? What was the other definition for speed? Speed was distance transversed in unit time. Distance transversed in unit time was speed. So what is velocity? Displacement transversed in unit time. So wherever you have distance, convert it to displacement. So velocity is going to be displacement transversed per unit time. Now children, then you might ask me, sir, now what is the unit? What is unit of displacement? Sorry, what is the unit of velocity? What's the unit of velocity? Unit of velocity is displacement measured in meters, time measured in seconds. So meters per second is again the unit of velocity. Now you might ask me, sir, then all are almost like same to speed. Then what is the only difference? See, speed is a scalar quantity. What about velocity? Velocity is displacement divided by time. Displacement is a scalar or vector. It's a vector. When you have a vector here, it will have a direction. Can you cancel the direction? No. Then the final answer will also have a direction. Then velocity is a scalar or vector. It's a vector. Velocity is a vector quantity. Velocity is a vector quantity. Velocity is a vector quantity. That's the main difference between speed and velocity. Speed is scalar quantity, velocity is vector quantity. Okay, then write it. Those who don't have the tute, write whatever on the board. Those who have the tute, first blank this, next you have two boxes, next blank this. Finish. Online students finish. Online people. Online people, have you done? Yes, right. Now everything is same like speed. Huh? Here now we define velocity. Next you have what? Uniform velocity or constant velocity. Yeah. Just guess and tell what is uniform velocity. If the object moves with the same velocity throughout the motion, it is going to be what? Uniform velocity. Then I'm going to do the same practical that I did before. What's the practical? I'm going to have an object here. I'm going to have the stopwatch. I'm going to start the motion and start the stopwatch. Now what I'm going to measure, I'm going to measure the velocity transferred in every 1 second. That's the only difference. Before I measured the distance transferred in every 1 second. Now I'm going to measure the displacement transversed in every 1 second. There you go. So same experiment is done. Same experiment is done. Same experiment is done. There you go. You have time. You have the displacement now. Time and displacement. Tell me, can you stop the time? Never. Time will be running in its own format. Time 0, time 1, 2 seconds, 3 seconds, 4 seconds. Up to what I get? 4, right? 4. Displacement 0. Displacement 0. Displacement 3, 6, 9, 12. In the tudes, make a correction. I have given you 5, right? Make it 6. Make a correction. It's 5 here given. Make it 6. 5, change it to 6. 5, change it to 6. 5, change to 6. 5, change to 6. Now I don't need to tell about how that first second, second, those things do. You all directly tell in first second, what is the displacement? First second means 0 to 1 second. What's the displacement? 3 meters. Second, what's the displacement? Again 3 meters. Again 3 meters. Third second, again 3 meters. Third second, again 3 meters. Fourth second, there you go, again 3 meters. Fourth second also again 3 meters. Now what can you see? Each and every second, displacement is always same. Then what we call this motion as? We call it as uniform velocity or constant velocity motion. Clear? Understood? Let's write. This table is given. Online students, those who don't have the tube, as you know, draw the table. And under that, write there displacement in first second, displacement in second, displacement in third second, displacement in fourth second, and fill them. Those who have the tubes also directly fill them. Under the write down, under the write down, if the displacement transversed, if the displacement transversed in every 1 second is same, 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 we call that motion as what? Uniform velocity or constant velocity. We call that motion as uniform velocity or constant velocity motion. 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 Clear? So now uniform velocity, constant velocity, you all understand. Tell me, in real life, can we go in constant velocity? Can we go in uniform velocity throughout? No. Actually, as I told, aeroplane, jets, those people can go. If you're going in road, never try to go in constant velocity or uniform velocity, right? Go. So at that time, we go how? Time to time, our velocity changes. We'll consider such a situation. We'll consider such a situation. Time will never change and time will always go in the same way. I'm doing the same experiment. I have an object. I start the motion. I start the stopwatch. Measure the displacement transverse in every 1 second. And I'm going to plot a table for that. Displacement is 0, 4, 7, 9, 12. 7, 9, 12. Now tell me. Now tell me. What's the displacement transverse in first second? How much? 4 meters. What's the displacement transverse in second second? 3 meters. 7 minus 4, 3 meters. What's the displacement transverse in third second? 9 minus 7, 2 meters. What's the displacement transverse in fourth second? 12 minus 9, 3 meters. What is happening? Every 1 second, displacement transverse is different. Then is it constant velocity? No. Is it uniform velocity? No. At that instant, we find some other thing. What is it? Mean velocity or average velocity. So basically, mean velocity or average velocity, mean velocity or average velocity means what? Use that one and tell, use mean speed, average speed and tell me. Total displacement divided by total time. Same. Total displacement over total time. Clear? Understood? Then tell me, in this motion, what's the mean velocity? What's the total displacement? 12 meters. What's the total time? 4 seconds. What's the mean velocity? 3 meters per second. That means every 1 second it is traveling 3 meters. Did it actually travel like that? No. First second it is traveling 4 meters. Second second it is traveling 3 meters. Third second it is traveling 2 meters. Fourth second it is traveling 3 meters. So it's almost near the average velocity, but not exactly the average velocity. Okay then. Now we all know what to do. No? Those who have the tube, as usual, fill this part. Those who don't have the tube, draw it, fill it, and after that, you have a dotted line. Keep that dotted line, and in that box, draw this. In the box, draw that. In the box, draw that. Those who have power cuts, don't worry. I'll do the recording. Right. Finished, right? Now under that, write down those who have the tube. There is a dotted line given. In the dotted line, write down. The dotted line, write down. When displacement transversed, when displacement transversed, when displacement transversed, in every 1 second is different. In every 1 second is different. In every 1 second is different. We find mean velocity or average velocity. Mean velocity or average velocity. Mean velocity or average velocity. Now do question number 9. Actually, example number 9. Example number 9. Those who don't have the tube can use the PDF. Under mean velocity section, example number 9. Once done, tell me. Once done, tell me. Right. Example number 9. Example number 9. The variation of the displacement measured with respect to the starting point of a child riding a bicycle in a straight path during each 1 second time interval shown in the table. Okay. I'll first draw the table. You have the time. You have the displacement. You have the time and the displacement. There you go. Time I told you can't ever change it. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 seconds. 0, 2, 4, 6, 8, 8, 8, 8, 8, 4, 0. When you get a question like this, don't directly go and start the question. When you get questions with tables, graphs, charts, first of all, analyze what they give. See, they have given some data from this. Time with displacement they have given. Time is going 0 to 1, 2, 3, 4 second. Displacement is increasing. It is increasing in same interval or different interval. Same interval. See, between 0 and 1, 2 meters. Between 1 and 2 again 2 meters. Between 2 and 3 again 2 meters. Between 3 and 4 again 2 meters. So same distance is transferred in each 1 second. So what kind of a motion is there from 0 to 4 second? Uniform velocity, right? Displacement is there. Uniform velocity motion is there. First of all, analyze it. Here you have uniform velocity motion. You have uniform velocity motion. Next, from 4th second to 8th second, what has happened to the object? See, from 0 to 4, fellow is increasing the velocity, increasing the velocity, increasing the velocity. Sorry, he is going with the same velocity, he is increasing the displacement. That means he has started, he is moving, he is moving, he is moving, he is moving. The moment he reaches 8 meters, what has happened? Time is going, he's at 8 meters. I think he's looking at something. He has stopped at that place and he started looking at something. Why? Time is going, he's at the same place. Is the displacement increasing? No. If displacement is not increasing, then we can tell from here to here, fellow is at rest, isn't it? From here to here, fellow is at rest. Next, what happens in the last 2 seconds? Displacement is reducing. That means what? First 4 seconds displacement increase. Next 4 seconds he is at the same place. Last 2 seconds displacement decreasing means he is walking behind and reducing his displacement. So last 2 seconds he is walking behind. He is walking behind. So here he is walking behind. Walking behind. Walking behind with the same velocity, uniform velocity or not a uniform velocity? Uniform velocity. See, he is walking behind. Each 1 second, how much of displacement is reducing? 4 meters here, 4 meters here. So in each and every second, 4 meters are reducing means he is walking behind also with uniform velocity. So he is walking behind also with uniform velocity. So initially he is walking front, then he is at rest, then he is walking behind. See, this is what is happening. Initially time 0, he is at 0 displacement. 1 second, 2 second, 3 second, 4 second with the same velocity he has walked. 5 second, 6 second, 7 second, 8 second, he is at the same place. 9 second, his displacement is how much? 4. 10 second, his displacement is how much? 0. That means he has come to the same place. So 1 second, 2 second, 3 second, 4 second. 5 seconds, 6 seconds, 7 seconds, 8 seconds, 9. Okay, so how is this motion going to be? 1 second, 2 second, 3 second, 4 second, 5 seconds, 6 seconds, 7 seconds, 8 seconds, 9, 10. This is how he's going. First 4 seconds he is walking behind. Next 4 seconds he stopped at 8 meter. Last 2 seconds he is walking behind. Now have you all analyzed very well? Once when you analyze, you can do the question very fast. See, what kind of motion has the child undergone during first 4 seconds? First 4 seconds, what kind of motion? Uniform velocity. Roman number 1, uniform velocity. Roman number 2, what is the rate of change of displacement during first 4 seconds? Rate of change of velocity, rate of change of displacement is what? Velocity. What is the velocity in first 4 seconds? Velocity equals displacement over time. What's the displacement? First 4 seconds, 8 meters. 8 meters. What's the time? 4 seconds. What's his velocity? 2 ms to the power minus 1. Got it? Right. Roman number 3. Roman number 3, I'll do here. Roman number 3. Give one word to describe the rate change of displacement. Rate change of displacement is what? Velocity. So that one word that they are asking is velocity. Roman number 4. What can you say about the motion of the child during the time period from 4 seconds to 4 seconds to 8 seconds? What has happened? He's at rest. At rest. Roman number 5. Describe the motion during the time interval from 8 seconds to 10 seconds. 8 seconds to 10 seconds, he is having a uniform velocity, but is it a child walking? Yeah, child riding a bicycle, but he is riding behind. Child is riding the bicycle behind with uniform velocity, which you can never do. Right? You can't ride a bicycle behind with uniform velocity. Right? So fellow is riding the bicycle behind with uniform velocity. Question number 6. Find the velocity of the child during last 2 seconds. Last 2 seconds. What's the velocity? This is but little confusing. Huh? Roman number 6. What's the velocity during last 2 seconds? Velocity is displacement over time. See, look at, now listen very carefully. Last 2 seconds. That means this and this. Last 2 seconds. Look at this. Where he is initially 8, where he is finally 0. Then what is his displacement in last 2 seconds? 8 meters. He is walking behind, that's a separate story. But what is his displacement? 8 meters. So his displacement in last 2 seconds is 8 meters. Some students take it as 0, that's wrong. Because we will have to consider both this last 2 seconds. Last 2 seconds, initially he is front, 8 meters front. Now he is 0. That means his displacement is 8 meters in last 2 seconds. So time is 2 seconds. What's the velocity? 4 ms to the power minus 1. Any correction you can make? Any correction, look, check and make. Aliris. Aliris, huh? Right. Now the last part, last theory, acceleration. Right. Right on the heading, acceleration. Listen very carefully. To learn about acceleration, you need to understand a very important concept. That is change in velocity. What you need to understand? Change in velocity. Change in velocity. Change in velocity. What do you mean by change in velocity? Change in something. Remember, change in something is final of it minus initial of it. Change in mass is final mass minus initial mass. Change in acceleration is final acceleration minus initial acceleration. Change in displacement is final displacement minus initial displacement. Then tell me, change in velocity is what? Final velocity minus initial velocity. There you go. Change in velocity is final velocity minus initial velocity. Very important theory. Huh? If I put it in words, I know you have there. You are there. But as the equation is looking a little bit bigger, what I'll do is I'll make it into smaller. Change in velocity, I'll just take it as delta V. Don't get scared to delta. Delta means change. I just wrote it as a symbol. Delta is change. Delta is change. So for change, I have written a delta there. Delta V is final velocity Vf minus initial velocity Vi. Final velocity minus initial velocity. Write it there. Online students, those who don't have tube, write there. Acceleration main heading. Under that concepts needed. Under that concepts needed. First concept, change in velocity. First concept, change in velocity. First concept, change in velocity. Another, write this equation. Another, write this equation. Remember, final velocity minus initial velocity. Not initial minus final. Final minus initial is change in velocity. Right, do with me. Example number 10. Example number 10. Example number 10. A racing bike increases its velocity from 50 to 75. Just on top of 50 right there. 50 is initial or final? From 50. From 50 means 50 is initial. So on top of 50 right there, BI. On top now you have 50 like this, no, 50 ms to the power minus 1. On top of 50 right there, VI, initial velocity, VI. 75 is what? Final. On top of 75 right there, VF. On top of 75 right there, VF. What they asking? Change in velocity. Change in velocity is going to be final minus initial. What is your final? 75 ms to the power minus 1. Initial 50 ms to the power minus 1. What is your change in velocity? 25 ms to the power minus 1. You all do example 11, example 12 and send me the answers. Do 11 and 12. Do 11 and 12. Huh? Remember, change in velocity can be negative as well. Now. It's a change, right? It can be negative as well. Don't get scared for negative. Question number 11. An aeroplane increases its velocity on runway from 0 to 100. Then what is initial velocity? 0. What is final velocity? 100. Then your change in velocity is going to be final velocity 100 ms to the power minus 1. Initial velocity 0. From there you have what? 100. 100 ms to the power minus 1. Question number 12. Question number 12 is different. Huh? An athlete slows down. Slows down means he is coming faster and he is going to slow down, become slower. From 30, that means initial velocity is how much? 30 ms to the power minus 1. To 10, then final velocity is how much? 10 ms to the power minus 1. But they're asking, what is the change in velocity? Change in velocity is final velocity minus initial velocity. Now be careful. What is your final velocity? 10. 10 ms to the power minus 1. What is your initial velocity? 30 ms to the power minus 1. Now tell me, maths. 10 minus 30. 10 minus 30, how much? Minus 20. Minus 20. Yeah? You should put the minus sign. Minus 20 ms to the power minus 1. Minus 20 ms to the power minus 1. So remember, change in velocity can be negative. Don't get scared when you get negative answers. Those who want, quickly write down. Right. Now we can go to acceleration. Now we can go to acceleration. I'll erase this part also. Now we can go to acceleration. Children, acceleration is defined as change in velocity divided by time. Change in velocity divided by time. If I write it, change in velocity is what? Final velocity minus initial velocity. Time I'll write as t. This is equal to what? Acceleration. So acceleration is final velocity minus initial velocity divided by time. Some students misunderstand it thinking acceleration is velocity divided by time. Wrong. Acceleration is what? Final velocity minus initial velocity divided by time. That means change in velocity divided by time. Clear? Now tell me, Acceleration is a vector or scalar? Vector. Why? We are dealing with velocity. Velocity is a vector, then acceleration is a vector. This is a vector quantity. Vector quantity. What can you tell about the unit? Change in velocity also has the same unit of velocity, right? Then velocity is ms to the power minus 1 divided by time. Time is s. Then the unit of acceleration is how much? Ms to the power minus 2. There you go. Clear? Understood? Now, what is the definition of acceleration? What's the definition of acceleration? I told you all. If something is divided by time, we tell it as rate. Then here, acceleration is what? Rate of change of velocity. Rate of change of velocity. Rate of change of velocity. Acceleration is rate of change of velocity. Okay? Fill it in the tute. Those who don't have the tute, write them fully. This one in one box. We have that one box. This one in one box. This one in the other nearby box. Did you all finish? Once done, tell me done now. Right, done. Okay. Then tell me, can change in velocity be negative? Of course, yes, change in velocity can be negative. Then tell me, can acceleration be negative? Yes, acceleration also can be negative. Why? If change in velocity is negative, acceleration can also be negative. So if you get negative answer for acceleration, don't be scared. Acceleration can be negative. We call it deceleration. I'll tell it later. Acceleration can be negative. Now take your tute. Question number 13. Last few questions for today. So all the theories are done. Next we have graphs. That is a different section of theories. However, important theories of motion on a straight line is done. Let's take 13th question. Let's do with me. A racing bike increases its velocity from 50 to 75. So what is the final one? 75. What's the initial velocity? 50. Time is given. They're asking the acceleration. Acceleration is equal to final velocity minus initial velocity divided by time. Final velocity is 75. ms to the power minus 1, initial velocity 50 ms to the power minus 1, time is how much? 25 seconds. That is going to be 25 ms to the power minus 1 divided by 25 seconds. How much? 1 ms to the power minus 2. Write this and do question number 14, 15, 16. 14, 15, 16, do. Never get scared when you get negative answer for acceleration. Huh? Right. Question 14. Question 14. Question 14. An aeroplane increases its velocity on runway from 0 to 100. Then what's the final velocity? 100. What's the initial velocity? 0 in 20 seconds. They're asking the acceleration. Acceleration is final minus initial velocity divided by time. Final is 100 ms to the power minus 1. Initial is 0 divided by 20 seconds. Acceleration is 100 ms to the power minus 1 divided by 20 seconds. Then acceleration is how much? 5 ms to the power minus 2. Okay, 5 ms to the power minus 2. Question number 15. Question number 15. An athlete slows down from 30 to 10 in 10 seconds. What is the acceleration? 30 to 10. Then what is the initial velocity? 30. What is the final velocity? 10. Time is given. Acceleration is going to be final velocity minus initial velocity divided by time. Final velocity how much? Final is 10 ms to the power minus 1. Initial is 30. We did it already. We found the change in velocity already. 30 ms to the power minus 1. What's the time? 10 seconds, right? 10 seconds. So acceleration is minus 20 ms to the power minus 1 divided by 10 ms to the power minus 1. How much? Minus 2 ms to the power minus 2. 10 seconds. 10 seconds. 10 seconds. 10 seconds. Okay, right? So they're asking the acceleration. Acceleration is negative 2 ms to the power minus 2. What does this actually means? Is he actually accelerating or decelerating? He's decelerating. But as they are asking the acceleration, you should give the value in negative. If they ask for deceleration, you should make it positive. Why? Deceleration word itself means that it's a negative acceleration, right? So when the word is meaning it's a negative acceleration, then you don't need to give deceleration as a negative one. Here they are asking acceleration. Acceleration is negative. In case if they ask for deceleration, deceleration is positive 2 ms to the power minus 2. Clear? Understood? Let's do the last one. Question number 16. Question number 16. A rocket capsule slows down from 200 to 50. Then initial is how much? 200. Final is 50. Time is given. We'll find acceleration. They're asking deceleration. We'll find the acceleration. Acceleration is final minus initial divided by time. Final is how much? 50 ms to the power minus 1 divided by 200 ms to the power minus 1 divided by 30 seconds. No? Acceleration is minus 150 ms to the power minus 1 divided by 30 seconds. How much? Minus 5. Minus 5 ms to the power minus 2. Wait. What we found? Acceleration. We wrote the equation for acceleration. Acceleration is minus 5 ms to the power minus 2. But they are asking there, are they asking acceleration? No, they are asking deceleration. Then wait a minute. Deceleration is same thing. You write it in positive way. Acceleration is negative 5 ms to the power minus 2. Therefore, deceleration is make it positive and write 5 ms to the power minus 2. Clear? Another word for deceleration is retardation. So even if they ask retardation, you write it in the same way. Clear? Clear? Understood? There is a block given right there. There's a block given right there. Negative acceleration is a positive deceleration. A positive deceleration or retardation. Okay, then enough for today. This whole week you all have free class. So join the Telegram group, right? Those are not there in the Telegram group, join the Telegram group. Those who are not there in the WhatsApp group, send me a message and get into the WhatsApp group also. Send me a message and get into the WhatsApp group also. So next week we'll be continuing the lesson. I'll be doing graphs. Very important. This is also important. Next part, graphs is also very important. I'll start graphs of motion. With that we'll continue the lesson. Okay. Okay then. Get home safe. You all stay home safe. Bye.